Well, first of all, remember the system of linear equations is basically two equations that are put together in a system, and the solution to a system will be a value of x and the value of y, so two numbers that will satisfy both of the equations and in the system. And by satisfy, I mean if you plug the numbers that you find for x here and here, and plug the number that you find for y here and here, the first equation will be a true equation and the second equation will also be a true equation. So there are three ways to actually solve systems, and the first one I will show you is how to solve systems of two linear equations graphically. So what I'm going to do is I'm going to graph this linear equation first and then graph this linear equation, and I will show you where to find the solution to this system. Well, let's look at this first equation. This equation is in y equals mx plus b form, so it's easy to graph. We're going to start by placing 2, which is the y-intercept on y-axis. And from that point, from 2 on y-axis, I will use my slope, 1 over 2, to go 1 up and over 2. So 2, and then I'm going to go up 1 and over 2. Remember, up 1 over 2. And then I connect these 2 points to get a line. Well, here is your first line. Now let's graph the second equation on the same coordinate plane. This equation is not in slope-intercept form. So you can graph it using intercepts. That's when you plug in 0 for x, find y, and plug in 0 for y, find x. Or you could get y by itself and use the exact same idea as we just did. So I'm going to use that second option because y is very easy to get by itself. All you need to do is take negative 2x and place it to the other side. So that's what I'm going to do. Take negative 2x, place it here, and that'll become positive 2x. And now look, y is by itself. So how to graph this? Well, y-intercept happens to come first here, and the reason I know that this is y-intercept is because it doesn't have an x. So negative 4 is your y-intercept. That's the first point to place on y-axis. And then you're going to use the slope to graph the second point. The slope is positive 2. That's the number next to x. And to graph it, I'm going to have to place it over 1 to have that fraction so that I count 2 units up and 1 unit over. So from here, I'm going to go 2 units up and 1 unit over. So that's your second point. Now I'm going to connect them, and that will be my second line. So here's my second line graphed, and remember, this was not a graphing question. This was solve the system of two linear equations graphically. Once you graph it, the solution to a system, meaning the value of x and the value of y that satisfies both of the equations in the system, is where the two lines intersect. So the point of intersection is right here, and what we need to do to give the solution is to find the coordinates of that point. The x-coordinate of the point of intersection is 4, and the y-coordinate of this point also happens to be 4. So the solution is 4, 4. Now let's look at the second system I have here. The first equation is in standard form, the second equation is in slope-intercept form. Again, with the first equation, you can graph using x and y-intercept or get y by itself and graph using the slope and the y-intercept. To graph this using intercepts, I will first find my y-intercept. To do that, I'll replace x with 0. Replacing x with 0 basically removes it from here. And what's left is 2y equals 2. Well, if 2y is equal to 2, what is y? Simply divide both sides by 2, and that gives you y equals 1. This is your y-intercept. That's the first point for the first line. Y equals 1 is the point on y-axis where the first line will cross that axis. Now we're going to find x-intercept. So to find x-intercept, I'll basically do the opposite. I replace y with 0. That eliminates this term completely and leaves you with x equals 2. So x equals 2 is the x-intercept for this first line. So that's my second point. Well, here is the first line for the first equation in the system. Now let's graph the second line. The second one is in y equals mx plus b form. So I will start at 3 on y-axis. And then I'm going to use the slope to go down 1 because that's negative. down 1 and to the right 2. From that point that I just placed, down 1 and 2 to the right. So I'm right here. Well, here is the second line that I graphed. Remember from the first example, the solution to the system was where the two lines intersected, specifically the coordinates of that point. Here, it looks like our two lines are in fact parallel. Parallel lines, those lines that have the same slopes, will never intersect. So the conclusion we can make for this system is that it has no solution simply because there is no point of intersection. So this is no solution. Now let's look at the final system. Negative 2x plus y equals 6. That's the first line. And then the second line is y equals negative 1/2 x plus 1. Remember, the solution is where the two lines intersect. So my point of intersection is right here. And it looks like the x coordinate of that point is negative 1.3 approximately. And the y coordinate is approximately 3.5. Negative 1.3, 3.5. This example actually shows why graphing isn't the best method to use to solve systems of linear equations. Despite the fact that I was using graph paper, I probably tweaked the line a little bit and they didn't cross at a nice point with integer coordinates. If you're using the software, it'll probably not happen. But because of this, there is two other ways that you could use to solve systems of linear equations without making an error like I just did. One more remark before we get into substitution and elimination. If so happens that you graph two lines and they are basically the same line, if you graph one line and you graph another line and it goes over the first line, in that case, you say that your system has infinitely many solutions. Hello everyone, today I will be showing you how to solve systems of equations using substitution method. And here I have an example of two linear equations that are placed in the system and we need to find a solution to the system. Remember that the solution to a system of linear equations is a pair of numbers x and y that will satisfy both of the equations in the system, meaning if you plug in the x and the y and back into each of the equations will be true. How do I know that substitution is a good method to solve a system? Substitution is useful when in one of the equations in the system, one of the variables, either x or y, is already by itself or is easy to get by itself. So if you look at the example that I have here on the board, in the first equation, y is by itself. This means that substitution is a good method to solve this system with. Because the first equation suggests that y is equal to 2x plus 12, we're going to take 2x plus 12 and replace or substitute y with 2x plus 12 inside of the second equation here. So instead of 5x minus 2y equals negative 29, the second equation will now be 5x minus 2, and then in parentheses 2x plus 12, because y will be substituted with 2x plus 12 equals negative 29. Now, this is an equation that does not have a y anymore, and I can easily solve it for x. So first step, I will distribute. That results in 5x minus 4x minus 24 equals negative 29. Now I will combine like terms. 5x minus 4x is x. Minus 24 equals negative 29. Now I will take negative 24 and move it to the right side by adding it. So the only thing that's left on the left side is x, and on the right side I have negative 29 plus 24, which is negative 5. So we have the value of x. Remember, the solution to a system is both the x and the y, so we have to now find the y. To find the y, you're going to take the value of x that you just found, and that's -5, and plug it back into one of the original equations in the system. Either the first one or the second one, it's up to you to choose. I will now replace x with -5 in the first equation. So that will give me y equals 2 times -5 plus 12. 2 times -5 is -10. -10 plus 12 is 2. So the solution to the system of these two linear equations is x equals -5 and y equals +2. And the solution to a system is often written as an ordered pair. So instead of writing x equals -5, y equals 2, you can write -5, comma 2 in parentheses. Remember, in an ordered pair, x always comes first. You should always keep in mind that with systems, you need to check your work, meaning you need to take your x and your y that you just found, plug them back into the original system, into both of the equations, and see if these values work. So let's see if x equals -5 and y equals 2 satisfies the first equation. So I'm going to check. So instead of y equals 2x plus 12, I will have 2 equals 2 times -5 plus 12. So 2 equals 2 times -5 plus 12. Let's see if it works. Well, on the left side I have a 2. On the right side it's 2 times -5, which is -10, plus 12, that's 2. So 2 equals 2. This one works. Now let's check the second one. So instead of 5x minus 2y equals -29, I will have 5 times -5 minus 2 times 2, because y was 2, equals -29. Let's see if this works. So 5 times -5 minus 2 times 2 equals -29. This is -25. This is 4. -25 minus 4 is -29. So -29 equals -29. The second equation also worked, which means the solution to our system is -5, 2. In addition to substitution method, there is a different way to solve a system of linear equations, and that's when a substitution method is not easy to be applied. Remember, substitution is easy to use if one of the variables in one of the equations is by itself, and that's not the case here. None of the variables in either one of the equations is by itself, so we're going to use a different method, and that's elimination. With elimination, you will be adding like terms of two of the equations vertically. So, for example, you will be adding -5x and +4x, 8y and 3y, and then 25 and -20. Let's try to add these terms now. -5x and 4x will add to -1x. 8y and 3y will add to 12y. And then after the equal sign, 25 and -20 will add to +5. The idea behind elimination is that when you are adding either x's or y's, they will cancel each other out. For example, if -5 is next to x in the first equation, and hypothetically, if you had a +5 next to x in the second equation, then the -5 and the +5 would cancel each other out. And that's not the case with this system. So one of the equations, maybe even both of the equations, will need to be adjusted so that one of the variables, either x or y, have opposite numbers next to them, like 5 and -5, 2 and -2, and so on. Because x's in the first and second equation already have opposite signs, I will try to eliminate x's. But you can absolutely eliminate y's by multiplying one or both of the equations by a number. So next to the x's, I currently have a -5 and a +4. So I need to make these numbers to be the same but opposite in signs. Well, good news is they are already opposite in signs, but I just need to make them the same. So it looks like it's probably easy to make a 4 into a 20 and a 5 into a 20. And then I will have a negative 20 next to this x and a positive 20 next to this x. How would I make a 20 out of 5 and how would I make a 20 out of 4? Well, probably multiply the first one by 4 and the second one by 5. Now, if I chose to eliminate the y's, I could multiply 8 by 3 and 3 by negative 8, and that would create a 24 here and a negative 24 here. Either way you choose to go about eliminating is fine. So since I'm eliminating the x's, I will be multiplying the first equation by 4. Now remember, I can't just multiply the negative 5 by 4 to eliminate the x's. I have to multiply all terms of the first equation by 4. So times 4 here, times 4 here, times 4 here. The second equation will be multiplied by 5. I don't need to make this 5 negative because the 5 and the 4 already have opposite signs here. So times 5, times 5, times 5. Well, let's see how this changes our system. Instead of negative 5x, I now have negative 20x. Instead of 8y, I now have 32y. And instead of 25, I now have 100. Here, instead of 4x, I have 20x. Instead of 3y, I have 15y. And then instead of negative 20, I now have negative 100. Well, let's see how this works. At this point, I'm going to add my like terms vertically. So remember, the whole point of doing this is so that x's will eliminate. And they will. Negative 20 and 20 is 0, so this is gone. And then 32 plus 15y here is going to be 47y, and 100 and negative 100 is a 0. So how to get y by itself now is to divide both sides by 47. If I divide both sides by 47, I'll get y equals 0. And that's the first part of the solution. Now I have to find the x. Remember, to find the x, I simply replace y with 0 in one of the two equations. It doesn't matter which one, I'm just going to go with the first one. So y becomes a 0 here. Negative 5x plus 8 times 0 equals 25. Eight times 0 is 0, so we left with negative 5x equals 25. To solve this, you divide both sides by negative 5. So x is negative 5. The solution to the system is negative 5 comma 0. What's left is to check this work and see if negative 5 and 0 work for both of the equations if you plug them back in. So let's see. For the first equation, I will replace x with negative 5 and y with 0. So that will create the following statement for me. Negative 5 times negative 5 plus 8 times 0 equals 25. So 25 plus 0, that's a 25 equals 25. This works. Now let's check the second equation. 4 times negative 5 plus 3 times 0. 4 times negative 5 plus 3 times 0 should equal to negative 20. 4 times negative 5 is negative 20. 3 times 0 is 0. Negative 20 plus 0 is negative 20 equals negative 20. This one also works. So the solution to our system is negative 5, 0.